Hello, Algebra. Today I wanted to talk about graphing exponential functions coming from section 6.3. So in the Desmos activity, you should have seen in the last slide this sort of very generic basic form of an exponential function. So I'm going to be kind of switching back and forth here. If I have something written in that form, sometimes they will write it like this with the dot for multiplication. Sometimes they'll put parentheses around the exponent. It really does not matter. Sometimes they'll even put a parenthesis around the base like that. So a lot of different ways that you can see it. But basically, I want to talk a little bit about what A does in the function, what H does, and what K does to an exponential function. I'll talk a little bit about B. Remember, B is your base. But we'll talk more about that when we get to section 6.4. So I'm going to use Desmos to demonstrate this. So this was the last slide of your activity that you were to do. And here in Desmos, I have a whole bunch of functions. So a lot of these functions come from your 6.3 homework assignment. One of the questions that came up is, if I have y equals 4 to the x, what happens when I put a negative in front? So I just went ahead and I typed both of those in. Remember that you can type those in by using this keypad down here, or you can just type it in by hand using your own keypad. So when I go to click on this one, we can see what happens is they look pretty much the same, but what happened to the original function, or what they call the parent function, is it is now flipped over the x-axis. So it looks like the function in black. Okay, so it's just flipped over, going in a different direction. Okay, so basically what happens whenever you make a negative, but if A is negative, it will flip the graph over the x-axis. So instead of now going up and to the right, it's going down as it goes to the right. So that's the difference. So this would be if it's a positive A, this would be if it's a negative A. Okay. All right, let's take a look at one of these other functions. Another problem that came up was, what happens if I take this original function and now I'm going to change the exponent? You can see in the exponent we have x plus 3. When I click on that to see what happens, you can see now the function here in green. Okay, the function in green has moved the plus 3 in the exponent has moved the red function to the left 3 spaces. And it may seem weird that there's a plus sign and it's going left, but that's because in the original form it's x minus h. And if h is negative 3, meaning you're going to the left 3, it creates this double negative, and that's where the x plus 3 comes from. Okay, so I always like to say with the h value, even though this isn't really technical, you're going to move it the opposite of what you see. So if you want to look at, so here, let's compare it to what happens if this were a minus 3. You can see that it goes there to the right. I'm going to put that back how it was. All right, so what happens with the h value is the h value, it basically just shifts the graph left or right h units. And I'm going to write a little note that it's opposite of what you see. Again, not very mathematically technical, but it definitely can help your brain to sort of think about it a little bit better. All right, let's see what happens when we have k. And then we'll do a little combination. So I'm going to use a different function, y equals 3 to the x. Again, this comes from your assignment. Okay, so we have y equals 3 to the x. If I go ahead and I subtract a number, you can see that it has moved down. Okay, and you can see that it's actually moved down one space, or 1 unit, not one space, 1 unit, because I have all the minor grid lines in here. You could change that to like a 4, a minus 4, and you can see that it goes down 4. Okay, so if I did a plus, you could probably assume that it's going to go up 4. There it is. It's going to go up 4, right? So that gives you an idea of what k does to our graph. So what k is going to do is it's going to shift the graph up or down k units. So for this one, I'm going to just write as you see it. Right, so it's not opposite like the other one. So we've talked about what a does to the graph, what h can do to the graph, and what k can do to the graph. All right, let's talk a little bit about our base. So we're going to talk about, there's 2 different bases that can happen, and we'll talk more about this in 6.4. But you can have a base that is a value bigger than 1, and you can have a base that is a value in between 0 and 1. Okay, so just to compare those 2. All right. Okay, so let's compare those 2. So here's y equals 2 to the x, a nice parent function or original function. And you can see that the base there is a value bigger than 1. If I change the base to a value smaller than 1, so a fractional value smaller than 1, so technically between 0 and 1, so not negative, because remember what a negative does, it flips it over, like this one up here. If I click on this, you can see what's happened is it's kind of turned it around, right? It's almost done like a flip in a different direction over the y-axis. But it's because for a bigger base, the numbers are growing. They're growing and they're growing and they're growing. And if I make the base even bigger, you'll see that they're going to grow even faster. So the bigger the base, the steeper it is. Okay, and then you compare all 3 of these. So the green one is when the base is 2, the purple one is when the base is 3, the red one is when the base is 4. So you can see as the base gets bigger, it just gets steeper and steeper. Okay, so when it's bigger than 1, we would say bigger base means steeper graph. Okay. The other thing that it means is that our graph is going to go like this. Right? All right. So let's see what happens with the other one. So I kind of gave you guys a little preview of that. So what it does is it kind of turns it around. So smaller base means that things are getting smaller and smaller and smaller as opposed to bigger, bigger, and bigger. So the smaller base of 1/2 means that it's sort of like things are disappearing, right? They never ever fully disappear because it never ever gets exactly to 0, but it gets really close. So I'm going to take that away for just a moment. Okay. And I just want to show you that if I make that base, let's see, let's do like 1/4 because that's smaller. Whoops. And we'll do, okay. You can see, here's the red graph. Do you see how it's getting, it's steeper, right? I could make this fraction bigger, like make it 3/4, and you can see that not as steep, okay? So the smaller the fraction, the steeper it is, okay? So smaller the fraction base, means it's going to be steeper. But what's different about this one is it's steeper in this direction over here, meaning this part over here is going to be steeper. So that's a little bit of information about the base. And we'll talk more about in 6.4 what these two types of graphs are called. So we can also do combination transformations. So taking original like y equals 5 to the x and doing a bunch of stuff to it. So not only have we, do like this. I'm going to move it to the right because the h is 2. I'm then going to move it up 7. Okay. So now for the domain and range, when you're talking about domain and range, what's unique about these exponential functions is that the domain is going to be what we call all real numbers. It'll always be that because it's going to go forever and ever left to right. For all real numbers, you can use the capital R symbol. It's a little bit more fancy than just capital R. And then for the range is always going to be y greater than some value or y less than, depending on where it is on the graph. So what I'm often looking at is how my graph has shifted up or down. So with something like this one, it would be y greater than 0. For something like this one, it would be y greater than 7. For something like this, it would be y greater than -1. So what you can see is that the range is closely related to the value of k. The value of k helps you to figure out the range, okay? And then when looking for your y-intercept, they do ask you for that. For the y-intercept, remember y-intercept is the point where x equals 0, so you could plug in 0 and find y, or you can just look where the graph crosses the y-axis. Okay, so I hope that this information helps you a little bit with your assignment. And this goes along with, again, with your 6.3 assignment. Please come to support if you have questions, and best of luck with your practice.